Kind of a video here on graphing systems of inequalities. We're going to talk about the basics of graphing two variable inequalities, a few examples, and a word problem example. This says two inequalities here. Y is less than or equal to negative 3 over 2x plus 5, and 5x minus 2y is greater than 20. The first one is in slope-intercept form. The slope is negative 3 over 2, the y-intercept is 5. So it's going to start at 5, it'll go down 3, right 2. The second one has an x-intercept at 20 over 5, which is 4, the point 40. And it has a y-intercept at the point 20 over negative 2, which is negative 10. That's the point 0, negative 10. So I have an idea this has to cover things at least from 5 to negative 10. So I want my axes to be rather far apart. I try to have a thought of where I want this graph to look, by which I mean like how far up and down to go, how far left to right to go before I start making it. But I think I'm just going to want a lot of space for this one. So here's going to be a nice big x-axis. Here's going to be a nice big y-axis. And I think I'll just count by ones. I think I can squeeze it all in there if I count by ones. So we'll go 2, 4, 6, 8, 10. With this grid, every box represents 1. I'm just doing every other to give myself some space. Okay, let me graph the first line. The first line was negative 3 over 2x plus 5. So it's going to start at 5, which is here, and go down 3, right 2. Down 3, right 2. Which I think is, my graph is off a little bit. It'll be here. Down 3, right 2, down 3, right 2. I can also go up 3, left 2, up 3, left 2. There. Here's my first line. Now because it has the equals 2 on it, because it has this equals 2 right here, it's a solid line. Had it been a not equals 2, I would have done a dotted line. But when it's this, it's a solid line. Now, before I shade above or below, I'm going to figure out where I want to shade. Do I want to shade above or below? I wrote up here that if you have the y variable by itself, a less than means shade below. And here the y variable is by itself, so less than means shade below, which means I'm going to be shading... Oh, you can't see that. That's a surprise to me. Huh, I'll do crayon. Less than means I'm going to be shading this side of the line. But another way to check that, and I haven't done my shading yet, it's like to figure which side I'm going to shade. One way to do that is to take a point and plug it in to the inequality and see if it works. We usually pick the point 0, 0, because 0, 0 is easy. If I plug a 0 in for y and a 0 in for x, that becomes 0 is less than or equal to 0 plus 5. Since 0 is less than 5, since that point works, this point works, so I would shade this side of the line. If that point didn't work, I would shade this side of the line. But it did, so I don't have to worry about that. So there's my first line. Now I'll graph the second line. It has a y-intercept at negative 10, which is here, an x-intercept at 4, which remember, 1, 2, 3, 4, this graph's a little bit off, is here. The x-intercept is at 4. And I can connect those dots. This is going to be a dotted line because it doesn't have the equals 2 on it. Now, you might need to find where these two lines actually cross. That might be of importance. To find where these two lines cross, I would take the two equations of the lines. I would write them with an equals instead of a less than or greater than, because I'm worrying about where the actual lines themselves cross. And then I would do substitution, elimination, or I could do it on my graphing calculator. Obviously, just graphing it by hand isn't going to help. It's not at a very clean point. But I could do it on my graphing calculator on my Desmos app. And I could find that actual point of intersection. So in fact, let me just do that real quick. I'll pull up my graphing calculator for this one. Oops, that's not my graphing calculator. That is. One of my equations is going to be y equals -3 divided by 2 x plus 5. The other equation is, I need this to be in slope-intercept form. So what I'm going to do is kind of do all the math at once. Like the first thing I would do is subtract 5x from both sides. I would subtract a 5x from here and subtract a 5x from here. Then I would divide everything by -2. And I can just type it into my calculator like that, and it knows what I mean. It knows what I'm doing there. Then I press graph. It's crossing somewhere in there. Second trace, pulls up my calculate menu, go to the fifth option here, which is intersect. Press enter a couple times, press enter again. It's at 3.75, -6.25. That decimal's not appearing very well, but there you go. That's what that point of intersection is. Now let's figure if I should shade above or below this line. I can't trust the fact that this is a greater than. I can't just see greater than and say, oh, that means shade above. That only works if the y variable is isolated. If the y variable isn't isolated, you have to do some algebra. So I can do 5x minus 2y is greater than 20, subtract the 5x, and -2y is greater than -5x plus 20. And when I divide everything by -2, don't forget this rule about inequalities. You divide everything by negative, and the sign switches. It becomes less than, which means I'm shading below this line also. I'll be shading here, below this line. I also could have plugged in the point 0, 0. If I plug in 0, 0, I get 0, you can barely see that, so I'll go back to my pen. 0 minus 0 is greater than 20, and that is not true, so I would not shade this point, so I would instead shade this side of the line over here. So what I'm looking for is the double shaded region, and the double shaded region is here. You guys see what I did there? I mixed blue and yellow to get green. You should be really proud of me. The double shaded region is there. That's what we're looking for. Every single point in that neck of the woods is going to solve the equation. If I pick any point in here, let's say that that's the point 4, -5. If I plug 4, -5 into this equation, it'll work. Plug 4, -5 into this equation, it'll work. Every point in that region works, including any point on this line, but not including any point on this line. That's the difference between the dotted and the solid lines. And if I picked a point over here in this region, it would work only in the first equation. And if I picked a point over here in this region, it would work only in the second equation. And if I picked a point up here in this region, it would not work in either equation. And every time I said equation, pretend I said inequality, because these are all inequalities here. So anything up in this neck of the woods would not work in either inequality. That's the section that doesn't work anywhere. That's what you're trying to find when you graph these inequalities. Find the spaces that work for all regions, and then maybe the ones that work for just one or the other. Let's do another example. It says 3 pieces to it. Y is less than -x, x is greater than -4, and y minus 2 is greater than -2 times x plus 3. That third equation is in point slope form, which I'll talk about in a second. I'm pretty sure that with this graph, just looking at the x values and the y values, I can use a pre-made grid. I think this grid here is going to work fine. Let's find out if I ever get it. Where'd you go? Come back, pre-made grid. Huh. Let me try that again. There we go. That's what I want. Just shrink it down a little bit. I was just looking at the fact that these numbers are relatively small, so they should be able to fit somewhere between -7 and 7. Okay, the first one I'll do is y is less than -x. Well, this has a slope of -1 and a y-intercept of 0. The graph's like this. It's going to be a dotted line. And the next question is, do I shade above or below? Since the y is by itself, less than means shade below, but I can also plug in some point to check. Now, I can't plug in the point 0, 0, because the point 0, 0 is actually on the line. So I'll plug in some other point. Say I plug in the point 1, 1, this point here. Well, it is 1 less than -1. It is not. 1 is not less than negative 1, so this point doesn't work, so I'm going to shade the other side. All this stuff down here. And I just do a little line first so that I know which direction I'm going to go without overcomplicating things. The next is the line x is greater than negative 4. And I'll do x is greater than negative 4 in green. If x is greater than negative 4, that's actually greater than or equal to going to be a vertical line. Whenever it's x equals, you're crossing the x-axis. If it's y equals, you're crossing the y-axis. If x is greater than negative 4, I'm looking for all the points that have an x value greater than negative 4. Well, this has an x value greater than negative 4. It's 1. This has an x value greater than negative 4. It's 5. Every single point over here has an x value greater than negative 4. I don't care about the y values, just the x values. So it's going to shade like this. So right now, I know I'm going to be looking at something in this triangle eventually. But let's see what this third line does. This third line is in point-slope form. And if you've forgotten or never learned how to graph point-slope form, it is magical. I think it's my favorite. You can, if you want, just distribute the negative 2. And graph that line. Just graph y is greater than negative 2x minus 4. But the point of point-slope form is it gives you a point. In this case, the point is negative 3, 2. You switch the x and the y coordinates. So this is the coordinate for x, negative 3. This is the coordinate for y, positive 2. I would go to the point negative 3, positive 2. And from there, do my slope down to right 1. Hey, all three of these have the same point of intersection. That's interesting. That's the point negative 4, 4. That was convenient. Nice clean point of intersection. This is going to be a dotted line. And it's going to be shading above. The point 0, 0 works. So if I'm shading above this line, that's everything here. So the triple shaded region, in this case the green line didn't actually make any difference. If we took out the green line it wouldn't matter at all. But the triple shaded region is going to be this. Everything in this triangle looking space is going to solve all three inequalities. I want things that work in all three inequalities. And then there's going to be some sections that work in just 2, some sections that work in just 1, and of course everything over here doesn't work anywhere. Good, next. Your parents have sent you to the grocery store. You are to buy somewhere between 2 and 7 avocados and no more than 8 donuts. And we have no idea what their plans are with these foods, but here we go. We're going to set up a system of inequalities and graph the feasible region. Between is a tricky word here. Because if I said pick a number between 2 and 7, you might wonder, well, can I actually use 2? Is 2 between 2 and 7? So usually we put the word inclusive or exclusive here. If it says inclusive, that means include 2 and 7. And we're going to assume that's what they mean here, that 2 and 7 avocados would be okay. If it was exclusive, that would mean don't include the 2 and the 7, so 3, 4, 5, and 6. So I want numbers that are between 2 and 7. Well, I can call this, x can stand for number of avocados. You might wonder, why not just pick A, Grant? It's because I'm annoying. So x has to be greater than or equal to 2, and x has to be less than or equal to 7. Another way we could write that is this. X is between 2 and 7. X is between 2 and 7. We also know that we have to make no more than 8 donuts. So y will stand for number of donuts. You could use d if you'd like to. We know that y has to be less than 8. It says no more, so we could have 8 itself actually, less than or equal to 8. I think again I can use this graph I had from before. It's got labels on it, and that's quite nice. I'm going to shrink it down again. I have to find a way to make this smaller next time in advance. And I'm going to graph on this plane here. Well, if x is between 2 and 7, I'm just going to start graphing with these lines. X is between 2 and 7 looks like this. but these should be solid. Anything in between those two spaces is going to work. Also, we want y to be less than 8. Well, if y is less than 8, let's pretend like 8 is up here. This is y is less than 8. And we're going to get anything in this neck of the woods. But now all of a sudden this seems really silly. We're not going to buy negative donuts. Right? Like if the y-axis is the donut axis, and stuff in here would mean a negative donut, and I don't want a negative donut. So there's two things here that we assume, but should still write down. X cannot be negative, and y cannot be negative. Right? Really, we need y to be between 0 and 8. Because we can't buy a negative donut. We don't really have to worry about that with the x's because they already said more than 2, and more than 2 is definitely more than 0. But we can't buy a negative donut, so there's also going to be a line here. And our feasible region is actually all of that stuff up in there. And I just used the term feasible region. Is that A? It's probably feasible. That means the stuff that works, the stuff that's possible. And we could even get even more specific here if we wanted to, because I'm not going to be able to buy a half of an avocado, and I'm not going to be able to buy a quarter of a donut. So the only points that work are actually going to be the whole number points. Those are the points that work. There are 48 of them. There are 48 different possibilities of things that I could buy. I could buy, at the extreme, 2 avocados and no donuts and pocket the change and be like, I did what you said, Mom, thanks for all this money. Or I could buy 8 avocados and 7 avocados and 8 donuts, just so we have as much food that we can possibly have, and they're guaranteed to go bad before we eat them all. But that's the possibility of everything that works. Now I'm going to jump over to one more problem. This is the exact same problem, except for we added one thing. For some reason, the number of donuts must be at least 2 more than half the number of avocados. This is the sort of thing that wouldn't happen in a scenario if you go into the grocery store, but there are plenty of scenarios where it can, like if you have coupons and if you have discounts and things you have to combine, things like that. You have this one extra condition. So what I'm going to do is take all the work we did on the last problem. Let's just get rid of this thing. Come on, go away. And take all of this and paste it over here. And drag it down a little bit. And now we're just going to throw in one more equation. If the number of donuts, well, that stands for y. Okay, so we have y. If the number of donuts y must be at least, meaning greater than or equal to, it could be equal to or more, so at least means greater than or equal to 2 more than half the number of avocados. That's y is greater than or equal to 1/2 x plus 2. That's the other equation we're going to have to sneak in here now. 2 more than half the number of avocados, and x stood for number of avocados. We lost this somewhere, but y stood for number of donuts. So I'm going to graph that. Start at 2, go up 1, right 2, up 1, right 2, up 1, right 2, down 1, left 2. It's going to be another solid line. They often come out solid lines. This is going to go like this. Suddenly our feasible range is way smaller because everything here is gone. It's just that little neck of the woods. Remembering that we had a line here. I'm not sure where the line went, but we had a line up here also. So now there are substantially fewer options that'll work. but still a lot. Inequalities, graph, shade, check. Thank you. Have a nice day. Hey, thanks for watching. I hope that was helpful. If you have any questions, leave them in the comments down below. There can be questions about the video you saw here or anything else in math I'm happy to help with. Subscribe if you'd like to watch more videos or see other updates as they come. I'm going to try to run through all of Algebra 2 Trig and then eventually hit more classes like Algebra 1 and Geometry and Pre-Calc and everything else. If you have questions about stuff covered that's not in this video, still let me know. I'm happy to help. And finally, if you're not one of my students taking the class, but you found the video and are watching it, or maybe you're a teacher and are watching it, you can buy the curriculum and buy the worksheets to go through it. That's found at the website listed down below also. So again, thanks for watching. Have a wonderful day.